What is AWS, and how does that impact Star Citizen? Such a simple question, and one that's going to take me a while to explain. Before we get into this, I need to state that everything I'm sharing here has been sourced from public statements. No proprietary information was used that is not available to the general public. This will be a very abbreviated view. There will be at least one episode in the podcast diving into details around how data centers function. So hit the subscribe button before you leave if you're interested in that. I think the best way to understand how data centers fit into the bigger picture is to follow a connection from an example user's home network to the data center. So we start with Joe wanting to play a game on his PS5. He fires it up. After all the work happens on his local network, the PS5 reaches out to Sony to log into their service. In this case, that service is hosted in AWS. So the traffic leaves the PS5, goes to Joe's router, then is forwarded to Joe's ISP. Joe isn't the only person in his neighborhood who is a customer of his ISP. So the first step for all of that traffic is to be aggregated from the many small customer connections into a larger set of circuits. The aggregation device then sends that traffic along. So Joe isn't lucky enough to have his internet provided by Amazon, which means that Joe's ISP has to figure out how to get his traffic headed in the right direction. This is done using BGP, or Border Gateway Protocol. There are two likely situations that come next. If Joe has a large ISP, like Comcast or Verizon, they will likely have a direct peering relationship with AWS nearby. That means that there is a connection between Joe's ISP and AWS that is only used to exchange traffic between those two networks. If Joe has a smaller ISP, they are likely buying transit service from a larger ISP. So the traffic has to cross Joe's ISP to the best location to be handed up to the transit provider, who then, you guessed it, transits that traffic to AWS. As a note, in the second example, it's possible to hop through multiple networks before you get to your destination. In nations with well-established networks, that is less likely. However, in places like South America or Africa, and even some places in Asia, they may have 3 or 4 networks to traverse before they get to their regional AWS data center. At some point, the traffic will reach the AWS data center. And we should talk about what exactly that is. I think most people still have this idea of data centers as converted warehouses, like they were 20 years ago. Today, data centers are some of the most over-engineered buildings we have. Not from the actual structural standpoint, though with the load they have to carry, they are quite impressive. Rather, from the services side. Let's take a moment and look at a few data center buildings. These are all in the Nova, or Northern Virginia area. We'll get into a bit more about why Nova matters to the internet later on. For now, let's just look at some of them while I share some stats. The largest data center I know about in this area is 2 million square feet spread over multiple floors. Each data center is broken up into zones with their own cooling, backup power, and network connections. You can see this in the pictures by the structures sticking off the side. Those are the AC cooling towers and massive generators. Between each of the AC and generators is normally a loading dock that services that section. They'll have shared elevators to get up to higher levels. Just in Northern Virginia, AWS has 58 data centers, up from the high 30s 5 years ago. Each data center is between 250,000 square feet and at least the 2 million square feet I mentioned above. Likely larger data centers have come online recently. The cultural home of the internet may be Silicon Valley. However, the heart of the internet, the plumbing making the thing work, has always been in the mid-Atlantic states, and most recently in Northern Virginia. This is the largest single grouping of AWS data centers in the world, and they don't even account for half of the data center usage along a corridor that runs northwest from Washington between Tyson's Corner and Leesburg. Each zone will have its own services: power distribution, cooling, network infrastructure, the works. The size depends on many factors, but we aren't talking a few racks here. We're talking row upon row of racks. Those zones will then be connected to each other to form a huge network mesh. This is done for two reasons. First, it allows traffic between AWS systems to route more directly. And second, it prevents the congestion of traffic onto core routers. This is a concept that's important, but this video is already going to run long. So just think of this mesh as a way to prevent any one location from being a critical path. So any one location can fail, and no one other than the AWS team would even know. Now, what's in those racks and how it's all connected? That's proprietary information, and it's constantly changing and evolving. It's also way deeper than is needed for the conversation we're having about AWS and Star Citizen. So for now, let's move on. AWS offers a ton of services, but they basically boil down to remote hosting of compute tasks. Depending on the service you choose, that could be a remote VM with an OS, or it could be a more advanced virtualization system, such as Docker or Kubernetes. In the early days, people would spin up an AWS instance to run complex models that they didn't have the CPU in-house to run. Since then, it has evolved to the point that you can deploy anything you want on AWS and have it run without any need for you to care about the networking or hardware or cooling. And that's the true value of the cloud. Not only can companies focus on the service they're trying to provide, but they can do so in a way that gets the benefit of one of the deepest engineering teams on the planet. In addition, with the financial power of Amazon, that group of engineers can build networks and compute clusters that were unheard of a short time ago. Everything in the world is a balance. It has to be. When I first started, a PM I worked with would start off any conversation about a job a customer wanted to quote on with a single question: fast, good, or cheap? Pick two. All of these cloud providers are battling to be the highest quality and the most flexible. So the cost of the service they offer is what you're sacrificing by using them. More on that later. Over the last 10 years, AWS has been able to invest, unimaginable amounts of money into their infrastructure. This isn't hyperbole. I literally can't comprehend having the budget they do. There are two reasons for the budget. One, scale. They had to build huge. They're just growing so fast. Two is that they had to reinvent what a data center is. I've touched on traditional data centers already, but let's define them a bit more clearly. The first generations of data centers were buildings with all of the physical infrastructure to run large deployments of servers or networking gear. They would be subdivided into different sized cages, and those cages would be leased out. I do literally mean cages here. They were enclosed in chain link with a locking door so none of the other customers could mess with your stuff. For the cost of the lease, the customer got a fixed amount of power, the cooling for that power, physical security, and a connection to the internet. Customers could then pay to connect their cage to someone else's, allowing for direct traffic exchange. This means that data centers of the day were hub and spoke. Big routers with a ton of ports sitting in the middle of the floor connecting to each of the cages. So what did Amazon do that was different? They spun up AWS just as virtualization was taking off. So rather than lease space, they moved to leasing computing capacity, meaning that Amazon would build a data center, fill all the racks with servers and switches, connect everything together, then let the customer run exactly what software or application they needed and charge them for the resources used. These are completely different business structures, to the point that even the design of the equipment used to run them had to change. And here's where the epic piles of money comes in. Amazon decided to make their own network gear. That's right, they spearheaded the production of white box switches, basically commodity hardware in small chassis that met the requirements for CPU, memory, ports, and capacity, but was open source and allowed Amazon to write their own OS to run them. This is what happens when you have a functionally unlimited budget and the people to make a goal happen. They redefined what a data center is by not making it a general networking solution. A network gear vendor like Cisco or Juniper would build solutions that had to meet the goals for their huge customer base. Amazon could build a switch that only did what they needed it to. This results in a narrowly focused device that is very good at doing a small set of things. And as you all know, when you can narrow the scope, you can improve the performance and reliability. So what did this get them? The ability to create the most fault-tolerant and reliable infrastructure that I've ever heard of. Thus, we end up at the power of AWS, reliability and ease. The reliability metrics are off the charts. Literally, most charts had to adjust to a new level of resolution to properly capture this. When it comes to ease, anyone can create an AWS account, spin up resources in any AWS location, connect those resources to each other, and with very little work, have a worldwide infrastructure to offer some service or other on. With the features of AWS, they could also build a service in Europe, fully build it out, and then just hit a few buttons and duplicate that service on every continent but Antarctica. I hope I've done enough to have your jaw on the floor with the scope of AWS. If not, let me give you one last number. AWS represents over 30% of the total cloud infrastructure on Earth. The offloading of responsibility for their hardware, networking, power, cooling, everything is not free. If you are running an AWS instance that is going full bore all the time, there's an economy of scale question that has to come into play. With an unlimited budget, I'd run everything I could in AWS, so I never had to think about it. However, most companies aren't working with an unlimited budget. AWS can get stupid expensive the more you use it. For one-off tasks, there's nothing better. Long-term services that aren't always running at the limit, also a great choice. However, when you're using CPU, memory, and network consistently, spinning up and down services, the costs add up fast. I'm about to make a statement that's going to get the trolls fired up. SIG needs to work with great care to understand the financial implications of running in AWS long-term for their production service. I can hear the mad tapping of keys, but 800 million. Let me just drop some reality on you people. In 2008, Activision paid a reported $29 billion for the Blizzard deal. Microsoft paid $7.5 billion for Bethesda. 800 million is chump change in the industry. These numbers sound big, and it is big for a public funding source. But in the tech world, it's mildly impressive given the source, but it ain't that big a number when you spread it out over 12 years. There was a single source I found that I can't corroborate, but my gut says the numbers make sense, so I'll share them. Just know this is an unsupported set simply to give you some scope as to my belief in the cost of using AWS. Sony spends $132 million a year. Facebook's $66 million a year. And finally, Reddit, $24 million a year on AWS services. I promise you, those aren't the largest expenses any of those companies have. I'm not at all worried about AWS as the host for Star Citizen. Frankly, the reliability of the infrastructure that would come with that would make me quite happy. A company like SIG, however, has to think long term. What happens when AWS starts turning the screws to maximize profit? Don't forget, none of these companies actually pay attention to the "don't be evil" marketing and mission statement garbage. At the end of the day, the dollar speaks. Let me boil my take on this down to a single statement. For every person CIG didn't have to pay to haul around servers and install OSs, they were able to hire developers or picking up a new studio of developers. The question isn't whether AWS will work. The question is, can a game like Star Citizen afford to pay the premium to outsource or not? If they can, they should. I want my game developers developing games, not building yet another international infrastructure to run it on. By having a small team of high-level networking professionals to guide the architecture within AWS and understand the traffic outside of the AWS umbrella, they can be sure that everything will work smoothly and have the expertise internally to keep the vendor honest. Now, I don't know who they have working for them, but given the talent they've attracted in other areas, I've got to believe they had their pick of the gaming-centric networking crew. I'm not going to second-guess them until I have some decisions or evidence that I disagree with. As long as the community doesn't have to think about the network, they are doing a fantastic job. Okay, that's all I've got for today. I have a feeling people are going to have a lot of questions on this one, so I'll be watching the comments section closely. If there's any interest from you all to dive deeper into any of this, just point me in the right direction. But I may have to decline or avoid some areas of conversation due to some obligations I'm currently under. Thank you for your time today. If you found value in this, please like. If you're interested in more content like this, please subscribe so you're notified when it comes out. Thank you.